Okay, welcome to the next video. In the last video, we were looking at factorizing quadratics, and we were looking at the case where a equals 1. What we're going to do in this video is make that a little bit trickier, and we're going to look at the case where a doesn't equal 1. Normally that means that a is a much bigger number than 1. So just a reminder that the general form of a quadratic is y equals ax squared plus bx plus c. So it's this a that we're talking about. So the number in front of the x squared is not 1. So we have to, it makes our life a little bit more complicated. Okay, let's look at a really simple example to start off with. And I'm actually going to start with the factorized form, expand it, and then show you the process for factorizing it again. So first of all, let's look at an example here. Y equals, in brackets, 2x plus 5 multiplied by x plus 2. Okay, so for this particular equation here, first of all, what we're going to do is expand it out. So if I use the FOIL method and multiply each term by each other term, 2x times x is 2x squared, 2x times 2 is 4x, 5 multiplied by x is 5x, and 5 multiplied by 2 is 10. If I group together these two x terms, then I get 2x squared plus 9x plus 10. So what I've done here is I've just expanded out the brackets. Now what I'm going to show you how to do is take this equation that we're left with and factorize it. Okay, there's a little trick that we have to use here. So you remember last video I used a little table of all of the factors of 10. I'm pretty much going to do the same thing again, but this time round I need to consider the factors of my first term as well. So what I'm going to do first in my table is I'm going to list the two factors of 2x squared, which are 2x and x. I'm going to put that at the start of my table. Now what I'm going to do is the same thing as my previous method, which is to list the factors of 10. So first of all, we've got 10 and 1, then we've got 1 and 10. We do need to do both possible orders. And then I've got 5 and 2, and 2 and 5. Okay, the next bit is a little bit of a trick. What we need to do next is we need to cross multiply these x terms with the factors over here and then add them up. So that means I'm going to cross multiply x to 10 and 2x to 1, and then add those together. So 2x multiplied by 1 is just 2x. X multiplied by 10 is 10x. If I add those together, I will get 12x. So that's just x times 10 plus 2x. Now I need to cross multiply my next factors. So I'm going to do x multiplied by 1, which is x, 2x times 10, which is 20x, which gives me 21x. For my next one, I get x times 5, which is 5x, 2x times 2, which is 4x. Add those two together, and we get 9x. And for my last one, x times 2 is 2x, 2x times 5 is 10x. Add those two together, and we get another 12x. Okay, what I can do now is I can have a look at this table and say, which one of these combinations of factors gives me my 10? Gives me my 9x, of course. Gives me my 9x. So if we go over to our table, you can see that this combination here is what gives me 9x. And if we look at the top row of our table, you'll see we've got 2x and a 5, which corresponds to our first bracket here. If we look down the bottom, we have an x and a 2, which corresponds to our second bracket here. So if I were to now use my results to factorize that, then I could write 2x plus 5 you'll have to excuse my handwriting, I'm just getting used to the tablet here, and then x plus 2, which we know from the start is the answer that we wanted. So I've done something a little bit roundabout here. Normally, you would actually be starting at this point and then having to factorize. What I've done here is I've expanded it and factorized just to show you what the process was. But that's our process. Okay, we're going to do another example and a tip. Okay, let's do another example. So let's say I get given this one here, y equals 2x squared plus 9x take 5. And I want to factorize that. Well, what we're going to have to do is we're going to have to go back to our little table, which I've just shown you. And same as what I did in the first example, I'm going to split 2x squared up into its 2 factors. So I'll just draw this a bit bigger this time. So that's 2, in this case, the only 2 factors of 2x squared are 2x and x. Now I'm going to take my -5 and list all of the factors of -5. Now, it's important to notice that I have to list both possible orders. So I'm going to go -5 and 1 and the different combinations of negatives. So -5 and 1, 1 and -5. And then I'm going to do +5 and -1, or -1 and +5. So there's a lot of combinations there, even though this is a relatively simple number, because of all the different combinations with the negative and the different orders. What I need to do next is do my cross multiplying. So as a reminder, I've got to multiply the x by whatever's at the top, the 2x by whatever is down the bottom, and then add the 2 together. So for my first combination here, x multiplied by -5 is -5x, and 2x times 1 is 2x, so that will be -3x. Next one, x multiplied by 1 is x, 2x times -5 is -10x. If I add those two together, I get -9x. My next combination here, x times 5 is 5x, 2x times -1 is -2x. If I add those together, I get 3x. Then my last one here, x times -1 is -x, 2x times 5 is 10x. If I add those together, I get +9x. And wouldn't you know it, my very last combination is the exact one that I'm looking for, because it's got a 9x in it. And remember, that's the second term in the equation, so that's the one we're looking for. So now my job is easy. I'm going to write out the factorized form of the equation, and I use the 2 values on the top line, so 2x and -1 to form my first factor. Then I use the 2 values on the bottom line, x and 5, to form my second factor. And then we have it. We have our factorized form of the equation. And if I want to check that, I can always just quickly expand it just to check. So 2x times x is 2x squared. 2x times 5 is 10x. -1 times x is -x. And -1 times 5 is -5. If I group the 10x and the x as we would hope, we get 9x take 5. So if we look at the original equation, that's correct. So we can give ourselves a tick. So one last example, just to illustrate that again. Let's go with y equals 4x squared plus 8x plus 3. So I've kept it a bit simpler this time and not had any negatives, but there is something a little bit tricky about the 4x squared that we need to just be aware of. So first of all, let's just do what we would normally do and list the 4x and the x as the two factors. If we look at 3, the number on the end, there's really only two possibilities there, 3 and 1, or 1 and 3. So if I cross multiply those and add them, 4x times x is 4x, x times 3 is 3x, that adds to 7x, x times 1 is x, 4x times 3 is 12x, which adds to 13x. We run into a bit of a problem here because neither of those possibilities actually adds up to 8x. But what we've missed is the fact that 4x squared has another possible combination of factors itself. And in fact, the other possible combination is 2x and 2x. So in this case, we need to do another table. And I'm going to list 3 and 1 and 1 and 3 again. And I'm going to cross multiply and add. So 2x times 3 is 6x. 2x times x is 2x. And if we add those together, we get 8x. And in fact, it's the same for the other one too. 2x times 1 is 2x. 2x times 3 is 6x, which gives us 8x. So it doesn't actually matter because these are both 2x. It doesn't actually matter what order this is in. And in fact, this has given us the answer that we're looking for, in that it gives us our 8x. Okay, so this is our answer then. So in factorized form, we take the top line, 2x plus 3, and the bottom line, which is 2x plus 1. And you can see it wouldn't have mattered which order I did it in because when you get to the end, it doesn't matter what order. Okay, so that's just something to be aware of if the very first term in the equation is something with multiple factors itself. These are a little bit trickier, but again, it's just a process of trial and error. And if you try all of the combinations, eventually you're going to get the right answer. Okay, thanks for watching.